these justification documents. Eventually there will be a bell ringer test. I do not know when, but it should come. Theoretically. It should come. And knowing me, because I am lazy, and because you should be doing justification questions. At least one, maybe two of the questions will be just simply turn in your justification question from specific Thursday. Like today. So if Cassie has nothing, she needs to fix that before I ask her to turn it in. I'm saying her name because she doesn't have nothing. Okay. Most people all day have overthought this problem. Everyone's trying to turn it into a proportion so they can cross multiply. I get 1 inch and 1 foot, and the second drawing was 1 inch and 6 feet. Which scale is going to give me more feet? The 1 inch to 6 feet. It's got 5 more feet per inch. We're going to have more feet per inch. For instance, if I said that my piece of paper has 20 inches, well then her first drawing could only be 20 feet. If I had 20 inches of space, her first drawing could only be 20 feet. Whereas I have 20 inches of space, her second drawing could be 20 times 6, which is 120 feet. That's much more. It can be a much bigger building. Okay, everyone's done all day, which I love you for dearly, have set up proportion and cross multiplied. Do you know why that is? Because that's what we just did in math class. So for now, it is on your brain. Of course, eventually I will need you to set up proportion and cross multiply, and guess what? You won't do it. But for now, this makes me happy that you were confused. I know that sounds sad, but I'm happy. The test, that's it. All I need is an explanation about how the 6 foot is going to give you more feet per inch. And so maybe it says, what is the scale factor? So 1 over 1 is a giant number. 1 over 6 is some decimal. Apparently, the smaller the scale factor, the more feet you're getting. So something about small scale factors being good. Savannah's looking for the perfect words. That I love her for. While Savannah searches for those perfect words on this bell ringer, you got off a day. So Monday you reviewed. Tuesday you tested. Yesterday, bless your hearts, you walked into the room on my all by myself day, and you had not even been introduced to the Pythagorean Theorem, and I asked you to do it all class period without really explaining things. I did one problem. I put it on the board. I said, color your barns. There are at least 2 in the room who never even started coloring their barns. You want to get your barn colored. This is sad, but I'm putting it, I gave you my whole class period for it, so I'm putting it in the 30% category. Did Cassie color her barn and try? Did she, and I even have a key. Does hers look almost exactly like, if not identical twin of my key? Great. Cassie can have her points. Cassie can only miss out on points if she doesn't turn in her colored barn. Cassie likes to color. She's not going to miss out on that. Are there any questions about the colored barn from yesterday? Then we've got to talk about what we're going to talk about today. Today we're only going to talk about that top learning target. Tomorrow's problem is the bottom learning target. We're seriously going to spend so much class time on this section. So, I get to tell you my whole rant. Chapter 7 was so much fun. It was. But you know what? If I could, like Groundhog's Day, teach one chapter over and over and over again, it would be Chapter 8. Chapter 8 is my favorite. Why is Chapter 8 my favorite? It's probably the most important. If you're interested in going on to Algebra 2 with trig next year, this chapter is going to help you with that. This is the most useful chapter in my mind. Not that all math chapters aren't useful, but I swear this one is the most useful. What else was I going to say? It's my favorite, and I'm super excited about it. I told them the other day, I got to teach this on Valentine's Day with them, that I was more excited about this than Valentine's Day. Because I am. So, do you have out your notes? Do you have out a color? We're going to go through this pretty quickly. Yes. Now, my only thought to tell you while she's turning that in and everyone's getting their life together is that 8.2 and 8.3 are such important sections, and they have so much stuff in them that we will actually have an assessment on just 2 sections before we do any more sections in Chapter 8. They're that important. In fact, I'm not going to do it to you today because it's your first day to spend some time with it. Well, besides yesterday's coloring thing. But I already have a Pythagorean Theorem checkpoint. That's how important it is. We're going to spend lots of time on it. I have bonus stuff available. We're about to get real deep, but we'll worry about that tomorrow. Let's just get over the dry hump today. Let's just get over there. Okay. Natalie needs to know the Pythagorean theorem. It's a squared plus b squared equals c equals. She already knew it. You probably already learned it in your algebra class. You've probably already seen it. That's all great. What I'm going to do is try to make sure Natalie can't possibly mess this up. So I'm going to focus on things she could do wrong. There is only one rule with the Pythagorean theorem besides to remember it. And it has to deal with the c. What does the c have to be? It has to be the hypotenuse. How do you find the hypotenuse in a triangle? It's across from the right angle. So what I do on every single picture so I can't mess this up is I draw an arrow from the right angle to the hypotenuse. The c is the hypotenuse every single time. So what someone who's not here or someone who's tuning me out is going to do is they're going to think, for instance, on number 1, the c is the x. On number 2, someone's going to think the c is the x. The c is not the x. The c is the 12. And I'm going to continue to draw all my arrows. And I always do that. And the reason I always go ahead and draw my arrows is so I can't possibly mess it up. There's only one rule. Well, actually, there are 2 rules. But the most important thing is that. Well, no, not even. Something important is that you cannot mess up which one's the hypotenuse. You cannot mess that up. I keep saying there's only one rule, and there's one other really important thing. And it's tiny, but it is important. That's why it is in parentheses. It only works for right triangles. Okay, so yesterday Natalie had this barn thing. She would work out a problem. She did a squared plus b squared. If it did equal c squared, she said yes. Then it would be a right triangle. If she did a squared plus b squared and it didn't equal c squared, then it wasn't a right triangle. Doesn't she wish I had said that yesterday before she spent all that time on it? Probably. I'm sorry. Okay, so we're going to do the first one. 4 squared plus 7 squared equals x squared. Will does not have to be my twin. He could do 7 squared plus 4 squared equals x squared and still get the same answer.
So it doesn't matter who you plug in?
It doesn't matter about A and B. It only matters which one you pick for C. Okay, what is 4 squared? What's 7 squared?
So is
Okay.
always going to be C?
No. Is XC on number 2?
Is the only reason why it's X because this is 90-degree angle across from there?
Mm-hmm.
So 12 will be C on number 2?
Mm-hmm.
Okay.
Okay, what is 16 plus 49? My math's off today. Okay, so 65 equals x squared. How do I get rid of the 2, the tiny 2? How do I?
Square root 65.
Okay, I take the square root of 65. That equals x. Okay, this is why we spend about closer to Christmas. We spend a lot of time on how to break down. This is called a radical. I tend to call it a house. We spend a lot of time on how to break the house down. What times what is 65? Times 5? Yeah, isn't that right? 13 times 5. Is 13 a perfect square? Is 5 a perfect square?
No.
So this is my final answer. This is what I want from you. I do not want and do not need, and those who are tuning me out are going to give me this, I do not need decimals right now. I need you to leave it like this. I need this. This is what I need. Okay. Sierra, oh brave one. Tell me how to set up number 2. Great idea. What is 8 squared? Somebody, anybody? Bueller.
4.
64 plus x squared equals what?
1.4.
Okay. I need to subtract 64 from both sides. Geez, you're on it. Okay, so I end up getting x equals the square root of 80. Cassie wants all the points she can get from me, though. She would love an A on this math test because so far it seems so good. Can she break down the square root of 80 any?
5 times 8.
It'd be 8.
How are you getting that? Did you ask your calculator? Okay. let's talk about how to break this down. You did this in your algebra class, and we did this in some bell ringers, but I get life's hard. So let's talk about it. I'm looking for a perfect square. A reminder, that's like 1, 4, 16, 9, 25, something like that. I want the largest perfect square possible to go into 80. For instance, I know 8 times 10 is 80, but neither 8 or 10 is a perfect square. Okay, 4 times 20 is 80. That is true. I heard those numbers. But there's a bigger perfect square than 4. What was it, Victoria? 16 times 5. So 4 and 20 are great, but we're looking for the biggest perfect square. So if Natalie circles x equals square root of 80, she's going to get most of her points. She's down to like a 97. Unless, I mean, maybe she doesn't mean that much, sure. But over a couple problems that could add up, she could blow an A. So what I do after this, so I know it's 16 times 5. I always tell my algebra kids, I give them a divorce. I'm sorry, it's sad it happens. So they live in separate houses. Do we know the square root of 16? 4. Do we know the square root of 5? No. So we're going to leave our answer as 4 square roots of 5. Now, if you have a genius calculator like Kaylee does, it does this for you. However, Lord knows I'm going to give Savannah more respect and possibly some more points if she shows me her thought process. Again, I was trying to think of what multiplied to 80. I knew 8 and 10 did, but neither 8 nor 10 is a perfect square. Or 40 and 2, but neither of those are perfect squares. So I went with 16 and 5 because 16 is a perfect square. Brister, go for it.
What I do,
Tell me what you do.
I just break it down. Like I'll do 8 times 10. And then I'll take 8 and I'll do 2 times 2 times 10. And then I'll take 10 and do 2 times 5.
Okay, so
I'll
Brister,
get my pairs.
What are the perfect squares?
4 times 5.
But sometimes I can't.
1, 4, 9, 6. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. We most often use 4 and 16. I don't know why. We just do.
2 square root of 2 and then 4 square root of 2 and then...
So I figured out, I always ask myself, does 16 go into that number? And if it does, I go with it. And if not, does 4 go into it? Because 4 does. Okay, but what Brister does, let's see, 4 times 5 is 20. 4 times 5 is 20 times 4. Okay. What Brister does is she breaks it down to prime factors. And she says, okay, so all the pairs get to go on a date. But if you go on a date, you got to sit at the same table. That's the best way to explain that. So you sit at the same table, and you get 4 square roots of 5. She's getting 4 square roots of 5 the same way. If you need more practice on this, I am an algebra teacher as well. I have lots of practice on this if you're wanting to practice this breaking it down. But you know me as the geometry teacher. I'm mostly focused on, did Sierra put the right stuff in the formula? Did she not give me a decimal? Thank God she gets most of her points. She's going from like 100 to a 97. It's not that big of a deal to me because if you did it in algebra, I swear. YouTube's going to hate me for that, but it's okay. Yes, you know my YouTube stardom. Okay. I need someone from Alexiana's group to help me set up the next one. Miss Brister, can you set up the next two? More apparently needs me.
Mr. Moore.
Mr. Moore. Can I say?
Oh,
Oh, Lord have mercy. You know how to do number 3? Who's going to set it up?
Do you know how to set it up?
I do.
They don't.
I do. Who knows how to set it up? Okay, help me out here. And look, I don't know what's it going to look like up there, but I'll try.
9 squared
Okay, 9 squared
x squared
plus x squared
equals 15 squared.
equal 15 squared. Okay, what's 9 squared?
81
81
plus x squared
plus x squared.
225.
225. Okay. So now we got to now we have to subtract 81. So we're going to have x squared
equals 144.
144.
Okay.
And 144 is a perfect square, right? Okay, so we're going to go x is equal to.
Stop.
Okay.
Why do you always pick Juliana?
Okay, so you did 9, 2, okay, I got that. Where'd you get 81?
Because 9 squared is 81.
Oh, okay. I
It's
did that.
comfortable.
Okay. And
Okay.
then you did
You need me?
that. Okay.
Everybody's confused.
Alright, and then you got x equals 144.
Yes. So take the square root of 144.
12.
Okay.
I'm sitting here looking at it. And
It's
then
confident.
the answer is 12?
To get
Yes.
the bar.
That's the
thing down,
answer
do I
is
press
12. Okay, so
Oh, yeah, I got it.
this one comes out really good.
Yeah.
And we'll
You
talk
don't
about
even
one
have-
in just a second.
You don't have to write this down. You know. Do you understand what I did? Everybody
Yeah.
sure? Everybody good on that?
Okay, I'm probably down.
Okay.
So you said.
So,
You're gonna. Oh wait, let me write mine down.
no, not with that. I need you to hit me with something else.
Okay, hang on. Let me write this down. I was wondering what she was doing. It's very easy. I love this. I love it
This is my
too.
favorite. I did this in algebra last year. I think algebra. I think I did algebra.
But then you do it in algebra too, also.
Yeah.
Okay. All right, y'all ready?
The people that know how to do this do not need to answer.
They don't? Okay.
I can't.
Okay, Natalie, tell me how you do it. How would you set the last one up, the number 4? What would you do? 5 squared, okay,
Plus 8 squared.
plus 8 squared.
Equal to 8 squared. I know how to do that. It's just when
Okay.
it comes to the.
Well,
the
put it into your put it in your put it in your
5 times
calculator.
5.
5.
Okay. Okay. What else?
4.
What? 64. Okay. Equal x squared. What's 25 plus 64?
25 plus 64. 89
89
is equal to 8.
Square that.
is x squared. Okay, so you say x is equal to the square root of 89.
And y'all can think about it, but I can't come up with anything that multiplies to 89. So that was my final answer.
Because I got a decimal.
Yeah.
It doesn't break down?
90,
Here, let me see that calculator, please.
I already did it.
I know, it comes out to me.
Yes.
That's 85.
Oh, I did 85.
Yeah. 89.
Wait, I have a question.
So if the answer right there, like.
That's it. You don't can't break it down, you just leave it right
Yeah,
there.
but if it's,
No, really?
If it's,
If you can break it down, you should. But you look, we worked 4 examples. There's only one that we broke it down on. So is that what we should be focused on today? No. We're focused on can you plug in the Pythagorean theorem and put everyone in the right slots. That's what I'm focused on. Can you do that?
do 80 like that, and then you did 144 like that.
I know the square root of 144 is 12, and that's actually a very specific one I need to talk to you about in just a second. But the 80, it's just because I knew stuff multiplied to 80, and one of them would be a perfect square. If you're stuck on that, I swear I have lots of practice sheets for you to figure out which ones would be like that.
And so
And again, Natalie right now, if she just left it square root of 8, she's only at a 97. It's not like she's failing the class. She's at a 97.
do you want to do anything A now because nothing multiplies into it?
Yes, that's exactly right. Okay, the last thing I want to say before I let you get to work, so if you hadn't noticed, you have, well actually no, we have a few more to do. Yes, Dylan.
So for number 4, could you add 8 and 5?
Of course. You can do 8 squared plus 5 squared equals x squared. You can pick different A's and B's.
Could you,
Okay.
could you add 5 to 8 and get 13 squared? Would that be the right answer?
No. You see, we're not doing a plus b squared. It's a squared and b squared all by themselves.
If you did combine it together, wouldn't it be like?
He would get the wrong answer. He does not need to do that. That is a good question. No,
Is it
I wish
equal
someone asked me that
169?
before. Yeah, that would be 169. We don't want that. Okay. Are there any questions about how to plug in the formula? So one last thing I need to tell you, which I haven't even told Brister, although she reads more than you do, so she's probably already realized this.
I don't read.
First and second have a Pythagorean triples quiz on Friday. 8th period's going to have it on Tuesday. This table tells you all the triples. These 4 or the 4 I would memorize. It's a 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. All the other stuff in the table is a multiple of these triples. For instance, 3 times 2 is 6, 4 times 2 is 8, and 5 times 2 is 10. So does Savannah actually need to memorize the other stuff in the table? No. If she knows 3, 4, 5, she's good to go. Same thing with 5, 12, 13. 5 times 2 is 10, 12 times 2 is 24, 13 times 2 is 26. Does she actually need to memorize the rest of the table? No. Would it be smart for her to recognize multiples of this? Yes. But Savannah needs a little more practice and stuff too. That's why the quiz is not till next Tuesday. Okay. For instance, now Savannah's going to ask the obvious question of, why do I need to memorize these triples, Miss Compton? And I get that. It's because, guess what? I don't have to do as much math when I know my triples. For instance, number 3, because I know my triples, I knew 9, 12, 15. I know 9 divided by 3 is 3. I know 15 divided by 3 is 5. And so I see it's a 3 and a 5. I can figure out that third side. It's a 3, 4, 5. What's 4 times 3?
12.
Oh, isn't that the answer Miss Brister got? So I do way less math than Miss Brister has to because I know my triples. I recognize that this was a multiple of 3, 4, 5. All the sides had just been multiplied by 3. So we're going to practice 2 on the back, and you're going to see lots of them on this worksheet that you either picked up yesterday or about to get handed today. If Natalie recognizes a triple, and she instantly knows the answer. For instance, she has her table. She knows 8, 15, 17 is 1. 8, 15, 17 is 1 on this sheet. She doesn't have to show me any work whatsoever.
How will we know if it's a triple?
It's one of these 4 or a multiple of one of these 4.
Wait, so you just divide by 3?
I didn't. If Natalie recognizes the triple because she's got them down, it's going to take her a while. She'll get them down.
Okay.
All she has to do on the test is put PT or something for me to know she recognized it was a triple. She doesn't have to show me any stinking work whatsoever.
So,
Just come to me, Smith.
Yes.
alright. So like these numbers right here, if one of these triangles had these numbers and like one of them was the answer, it would be this. Okay, but what if it's not?
Then it's not a
I
triple.
think it's because I'm all.
It's
So
either
there's
one
gonna,
of-
so there's gonna be some that there's
It's
not.
going to be a multiple of one of these. Like, look.
Oh, I got it.
Look, it's missing that side. It's going to be 8. Or 7, 24, it's missing this side. Look, what should be the number on that side? 724. Okay, so Natalie's catching on. Everyone can use their table today. Flip to the back for me. So for instance, you can either work out with the Pythagorean theorem. Sierra can always do x squared plus 24 squared equal to 26 squared. She can, but it'd be so much better if she could recognize a triple. Look at your front table. Do you know what x is supposed to equal? 10. Okay, how is Sierra figuring this out? Well, she used her table. But how she should know is 26 divided by 2 is 13. 24 divided by 2 is 12. I'm telling you, 5, 12, 13 is one of them. 5 times 2 is 10. So I'm always able to use my triples to figure out the third side. I don't actually have to use Pythagorean theorem. Yes,
How do you
dear.
know what to divide by?
I try to figure out what goes into both. So look at the next one. What goes into 36 and 39?
No, I'm not talking about that. I'm talking
Use your
about
table.
Okay, okay. I'm not talking about
What
that.
goes into 36 and 39?
36.
No, it's too big. 3. What's 39 divided by 3? 13. What's 36 divided by 3?
12.
What triple do you think this is then?
5, 12, 13.
It is a 5, 12, 13. If I divided all the other sides by 3, shouldn't I undo the 3 and multiply by 3? What's 5 times 3?
15.
The answer for the second one for number 6 is x equals 15. If you flip to the front chart, you'll actually see 15, 36, 39 as one of the listings. Okay, is everyone cool till here? I'm going to let go of I need to do my ladder one. I'm going to let go of my ladder one for now because Lord knows we all just need some time to practice.